This is Saritha, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering. Today's session I am going to explain about enhancement through point processing. Here, so what is mean by enhancement? So in our image processing, after completion of transformation, we can go for enhancement. So with the use of this enhancement, we can increase the picture quality. And after completion of this enhancement, that image is more suitable for the specific application compared to original image. So in this image enhancement, we are having different types of techniques are there. So how we can improve the quality of the image, how we can improve the picture quality and contrast of the image, and with the use of this enhancement we can remove the noise of our original image. So how we can remove noise in our image means with the use of filters. Filters is nothing but remove the noise components. Here in this we are using average filter, median filter. With the use of those filters, we can remove the noise components. In this we are using Butterworth filters and Gaussian filters also. Low pass, high pass, Butterworth low pass filters, high pass filters, Gaussian high pass and low pass filters. So with the use of filter, in low pass filter used for smoothing of the image, high pass filter is used for sharpening of the image. So in this image processing we can go for a two method. One is spatial domain, another one is transform domain. So in this image enhancement is a technique. So it is designed to improve the quality of an image. That image is perceived by a human being. And image enhancement can be performed both in spatial domain as well as frequency domain. So what is the difference between spatial and frequency domain? Means spatial domain means we are operating directly on a pixel. So in image we are representing in the form of pixels only, So we are in a when we go for spatial domain, we operate directly on pixels only. Whatever the resultant is there, for example, this is original image. This is target image. So we are operates directly on this pixel. Whatever the resultant value, that resultant value is stored in same pixel of the target image. So this is nothing but spatial domain. So when we go for in frequency domain, we are applying the transformation function on our image. Afterwards, we can go for the spatial domain. So here the main objective here it is improve the image quality, and here image enhancement we are using different algorithms are there. So those algorithms we are implemented in the MATLAB only. Here image enhancement algorithm is one that earlier better quality image. So for the purpose of some particular application, depending on our application, I want to increase the contrast level. I want to increase the enhance the image means picture quality is increased. How we can improve the picture quality? So whatever the image is there, in that image we need to consider pixel values. Each and every pixel has its own gray level value. So I need to improve the picture quality, brightness. I need to improve the brightness of all my image. So here for that case consider a constant value. That constant value at each and every pixel. So for that case, if I am adding here in this pixel, the gray level value is 50 only. My constant value I am representing with k. Here k value is also 50. So I need to add each and every pixel with this k value. Then what will happen? Each and every pixel value is increased by 50. Then the brightness of the image is increased. So I want to reduce the brightness of the image. Then what will happen here? Subtract this k value with each and every pixel. Subtract each and every pixel gray value with this 50. Then what will happen? The brightness here, for example, 50. So 50 minus 50. Then what about this pixel value? Here the pixel value is 0 only. Here the pixel value is 0 only. So initially it is 50. 0 means completely this pixel is 0. This pixel, the color here it is 0 only. So based on this, we can increase and decrease the brightness of the image. Increase and decrease the brightness of the image. Here, for in image enhancement, we are using sharpening or smoothening image features for display and analysis. So for that case, we are using low pass and high pass filters. So in this enhancement methods are application for specific often developed. So image enhancement techniques emphasis for specific image features to improve the visual position of the image. So if we are increasing the brightness of image, so that is clear to that gives the clear and improve the visual perception of an image. So here image enhancement techniques can be classified into two categories. One is a spatial domain method, another one is transform domain method. In spatial domain method is nothing but where operates directly on each and every pixel, whatever the resultant value is stored on same location. So like same location of the target image. For example, this is original image, this is target image. So I am applying the spatial domain method. So directly operated on a particular pixel only. Whatever the resultant is there, that resultant is stored in same location of the target image. In this spatial domain method operates directly on pixels. Whereas the transform domain method, here observe, transform domain method operates on the Fourier transform of an image and then transform it back to the spatial domain. So in this image enhancement, basically how we can improve the contrast of the image. For that case, we can go for point processing techniques. In this, we are having different types of techniques. So the one basic technique is histogram technique. So in this histogram technique, we are having histogram mapping and histogram equalization. So with the use of histogram mapping and with histogram matching and histogram equalization, we can improve the contrast of the image. So how we can, if any image is there, so how we can describe the contrast of that image means with the use of this histogram technique. So in this histogram technique, they are simple, it gives a fast and simple technique, and with them acceptable results for some application can be achieved. So here unsharpening. So unsharp masking sharpens. In this we are having low pass filters and high pass filters. Low pass and high pass filters. With the use of low pass filters, it gives smoothing of image. With use of high pass filter, sharpening of the image. Here, the edges of subtracting a portion of a filter components from the original image. So unsharp technique is nothing but with the use of masking has become a popular enhancement tool assist the diagnosis. What is mean by masking? Masking is nothing but this is my image. So in this image, I need to change the value of this particular pixel. Then I need to apply the mask. Here the mask size we are representing with 1,1, 3,3 and 5,5. Here this is my center pixel. So for this case, I am applying 3 by 3 mask. So 3 by 3 mask. Here I am applying a average filter depending on our requirement, either average filter. So with the use of different filters, whatever the resultant is there. So that resultant, so here W1, W2, W3, here W4, W5, 6, 7, 8, 9. So if go for average filter, W1, W2, W3 plus 4, 5, 6, 7 by total. So do the average of these all pixel value, whatever the resultant value, that resultant value stored in a this location only, that resultant value stored in this particular location only. So this is nothing but masking operation. So in this enhancement we are having point processing and masking operation. So next one is image negative. So what is mean by image negative? In the name indicates negative. So here this is input representing with R, here it is S, here it is output. Here 0 to L minus 1, the gray level value from 0 to L minus 1. Here 0 is the minimum gray level value and L minus 1 is the maximum gray level value. 0 is the minimum and maximum is L minus 1. Here R is the input. S is output. Here what is the formula here? The formula we are representing here, S equals to L minus 1 minus R. Here S equal to L minus 1 minus R. For example, R is nothing but input, S is the output, L minus 1 is the maximum gray level value. If R equals to L minus 1, what about output? Here output is S equals to L minus 1 minus L minus 1. Then S equals to 0 only. If R equals to 0, what about output? If input R equals to 0, then S equals to L minus 1 minus 0. Then output equals to L minus 1. Here output equals to L minus 1. This one is input. Here it is output. In this case, if input is 0, then what will happen? Input is 0 means here input is 0. Then output is maximum gray level value. So 0 means black. Here consider two conditions. 0 means black color, L minus 1 is the white. So complete white. Here if input is 0, then output is white color. If input is maximum gray level and output is 0. So observe here in this image, this is our input image. Here it is input image. Here it is output image. Here in this input image, this part, so observe here this part, it is black color. This part is black color. So what about output image? Input is black means here it is 0. R value equals to 0. What about output? S equals to L minus 1. This part, observe this part. In this part input is L minus 1. Input equals to L minus 1. What about output? Here output is 0. Compare this particular part. Here it is white. What about here? Input it is L minus 1. What about our output? Is 0. So here in this image negative, if our input is white color, so that is we are representing with L minus 1, then R equals to L minus 1, then S equals to 0. And if R equals to 0, S equals to L minus 1. R is input and L minus 1 is output. L minus 1 is output. So this is nothing but image negative. This is nothing but a image negative. Next, here log transformation. In this log transformation, S equals to C log R plus 1. So depending on if R value is changes here, this is the inverse, and nth power nth root and negative. Nth power nth root and here it is inverse. So this line we are representing with identity. Identity, here it is log transformation, here nth root. So in this case, this is log, this side it is inverse log, here nth power. So with the use of this log transformation, entire image space is not required. So entire image space is not required to analyze the image. So I want to choose some specific pattern. So no need to consider entire image for analyzation. So this is the use of log transformation. So I want to take some portion only. So no need to consider the entire image. No need to consider entire space is not required to analyze the image. I want to take a portion. I want to take a portion of the image. So with the use of this log transformation, this part is here it is representing like this. So I am applying the log transformation. The image is very clear. So increase the size, increase these white parts, and the image is increased. So enhance our image with the use of log transformation. And here power law transformation. In this power law transformation, S equals to R power gamma. Here C equals to 1 constant value, gamma equals to 1 by 2. Here with the use of this power law transformation, we can increase or decrease the contrast level of the image. We can increase or decrease the contrast level of the image. For example, here initially I have 2. So depending on R value, the gray level value changes from 2 to 8, for example. Or here 8. So depending on R value, it changes to 2. So here C equals to 1, gamma equals to 1 by 2. R value, if R equals to 2, it is increased. If R equals to 4, the contrast value, the gray level value is increased or decreased. So the image clarity, the brightness of the image, we can increases or decreases with the use of power law transformation. In this power law transformation, input gray level we are representing with R, and output gray level we are representing with S. Here the minimum gray level value, here it is 0. 0 means minimum gray level value, and maximum gray level value is L minus 1. Here also maximum gray level value is L minus 1. Here 0 means it is minimum gray level. Here it is maximum gray level. Here L minus 1 is also maximum gray level. So here 0 means it is minimum gray level. With the use of power law transformation, we can increase or decrease of the gray levels or contrast of the image. We can increase or decrease the gray level value. It is also contrast of the image. And here based on gamma values, here 3.0, 4.0 and 5.0. So depending on gamma value, images are represented here. If gamma equals to 3.0 or 4.0 and 5.0, here the C value is constant only. Here C value is constant for all the images. C value is constant here, but gamma values changes from 3, 4 and 5. So based on that, here the images are, so here depending on gamma value, the contrast level increased and decreased. Here in image enhancement in spatial domain. So image enhancement in spatial domain techniques, in this we are having classified into two types. One is point operation and second one is mask operation. So point operation and mask operation. So what is mean by point operation and mask operation, and third one is global operation. Third one is global operation. So image enhancement in spatial domain we are having three types: point operation, mask operation and global operation. Here point operation. In this point operation, each pixel is modified by an equation that is depending on other pixel values. So that point is shown in our figure. For example, in this point operation is represented by g of g of m comma n. Here g of m comma n is the output. So this output is nothing but a transformation of our input image. Here f of m comma n is the input image. So we are applying the transformation. Then what about our output? We are representing g of m comma n, g of m comma n. So here in point operation, t operates on one pixel. T operates on one pixel, or there exists one to one mapping between the input image f of m comma n and the output image is g of m comma n. In this point operation, we directly operates on particular pixel only. So in this, in general expression, f of m comma n or f of x comma y. So we can represent in both ways, no problem here. G of x comma y equals to t f of x comma y. Here it is origin. In this, for example, I am applying point operation in this particular pixel. So what is the resultant value stored in same location of the target image? This is our input image. This is our input image. Here it is output image or target image. So I am applying the operation. I am applying the operation directly on this pixel. Whatever the resultant value that is stored in our target image with same location. For example, I am applying the function on operation on this pixel. Then it stored same location. Stored in same location. For example, I am operating here. Then the resultant is stored in same location of the target image. So this is nothing but point process. So in this point process, input image is f of x comma y and output image is g of x comma y. Here f of x comma y is our input image, operates on this particular pixel only. Whatever the value is there, the resultant value is stored in same location of the target image. Same location of the target image. So here input image is f of x comma y and output is g of x comma y. So whatever the input image we are representing with f of x comma y, we are applying the we are operates a function directly on this pixel and resultant is stored in same location of the target image. And mask operation. So in this mask operation, each pixel is modified according to the values in small neighborhood. So example for this mask operations are spatial low pass filtering. Spatial low pass filtering using box filter or median filter. So in this median filter, for example, if you are considering 3 by 3 mask, in this how many pixels are there? total 9 pixels. So median filters is whatever the middle value is there. So for example 1, 2, 3, 4, 5, 6, 7, 8. So 9. In this middle value is 5 only. So in 3 by 3 mask, in 3 by 3 mask, so this total is nothing but 3 by 3. Each and every pixel 1, 2, 3, 4, 5, 6, 7, 8, 9. So with the use of median filter, 5 value. So in target image, here this is the 5 value. Here in same location, this is our original image. We are applying the median filter. This is our target image. Whatever the resultant is there, that resultant value stored in this pixel only, center pixel only. So this is nothing but median filter. So in this we are having average filter and median filter. Depending on our requirement, we are using any one of the filter. In mask operation, the operator T operates on the neighborhood of pixels. Here, for example, in mask operation, consider this pixel only. So in this image, consider this pixel only, but we need to consider neighborhood pixels also. This is my pixel we are representing. For example, it is f of x comma y. So we need to consider when we are applying the mask on this image, we need to consider these pixels values also. Here T operates on the neighborhood pixels. Here, mask is a small matrix whose values are often termed as weight. So each mask has an origin. For example, here in this we are having the mask sizes are 1 by 1 or 3 by 3 or 5 by 5. So for non-symmetric masks, any pixel location may be chosen as the origin depending on the intended use. So observe here in this So observe here, this is our entire image. So this is our entire image. We are representing with f of x comma y. I need to change the value of this pixel. So I am applying mask here. This is my mask. Here the size of the mask here it is 3 by 3. Size of the mask here it is 3 by 3. So in this we are using different types of filters. Whatever the resultant is there, that resultant is stored in center pixel. So here, here from left 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. The resultant value stored in center of pixel. For example, I need to change the value of this pixel. At that time, we need to apply the mask. Here it is 3 by 3 mask. So whatever the resultant is there, that resultant is stored in same location. That resultant is stored in same location of the target image. For example, I need to change this pixel value. Then apply the mask here. Here it is also 3 by 3 mask. So whatever the resultant value is there, that resultant value is stored in same location. Same location. Stored in same location. So this is mask or sub image. So here in this apply the mask on this original image. Whatever the resultant is there, that resultant is stored in same location of the target image. Here the target image we are representing with g of x comma y. So here point operation, this is the example for point operation. Here f of m comma n, output is g of m comma n. Here this is I am applying the function on here. The resultant is stored in same location. Here mask I am applying here. Whatever the resultant is there, that resultant is stored in same location of the target image. So this is the point operation and point processing. Examples for point operation and point processing. Next, global operation. In this global operation, whatever the image is there, so we need to consider entire pixel values. We need to consider entire pixel values. All pixel values in the image are taken into consideration for global operation. So usually it is a frequency domain operations are global operations. So enhancement through point processing here. In point operation, each pixel value mapped to a new pixel value. For example, here already I explained in this case. Here, consider any one image. In this is pixel. So I am applying the operation on this pixel. This here the gray level value is changed. That gray level value is stored in same location of the target image. So here each pixel value is mapped to a new pixel value. Here for example 25, the gray level value is 25. Here whatever the value is stored in target image means here here each pixel value mapped to a new pixel value. Here compared to 25, here the pixel value either increased or decreased, that is stored in same location means each and every pixel value is mapped to a new pixel value. And here the point operation are basically memoryless operations. In a point operation, the enhancement at any point depends only on the image value at that point only. Image value at that point only. So here some gray level value is there. So applying the point operation, the resultant stored in this location. So here image value, it depends only on the image value at that point only. Here the point operation, here input image we are representing with f of m comma n, and output image we are representing with g of m comma n. Here obviously each and every pixel of f of m comma n is the input image with same gray level maps to a single gray value in the output image. So here in these point operations, we are having brightness modification, contrast manipulation, and histogram manipulation. What about brightness modification? I need to increase the brightness of my image. I need to decrease the brightness of image. So how I can increase the brightness of image? How I can decrease the brightness of image? So for that case, this is my input image. This is my output image. So input image we are representing with f of m comma n, and output image we are representing with g of m comma n. Then here f of m comma n plus k. K is nothing but constant value. Here for example the image size is 3 by 3. Total in this we are having 9 pixel. Each and every pixel add with some constant value. That value we are representing with k. In this 3 by 3 matrix we are having total 9 pixels. Each and every pixel add with some constant value, that is k. Then we can increase the brightness. How we can decrease the brightness of an image? We can subtract each and every pixel with some constant value. Here in that case, g of m comma n equals to f of m comma n minus 5. So with the use of this one, we can decrease the brightness of the image. So here brightness of the image is basically depends on the pixel values or gray level value. When changing the brightness of an image, a constant is added or subtracted from the luminance of all sample values. Here luminance is not but gray level value. Each and every pixel has its own gray level value. If we are increasing that gray level value of each and every pixel, we can increase the brightness of the image. If we are subtracting the each and every pixel with some constant value, then we can decrease the brightness of the image. So how change the brightness? Brightness modification means increased by adding a constant value to each and every pixel of an image. Similarly, the brightness can be decreased by subtracting the constant value from each and every pixel of the image. So the brightness of the image can be increased by adding a constant value of each and every pixel. We can increase the brightness, and similarly we can subtract the each and every pixel with some constant value, and we can decrease the brightness of the image. Here, increasing the brightness of the image we are representing with sample A, and increase the brightness value of an image, add some constant value of each and every pixel. Here, if input we are representing f of m comma n, and here the resultant image we are representing with g of m comma n, g of m comma n, g of m comma n. Here, if f of m comma n represents the original image, whatever the new image is nothing but resultant image, we are representing with g of m comma n, obtained by adding constant value, that is k, to each pixel of input image, that is f of m comma n. Here how we are representing the output image, g of m comma n equals to f of m comma n plus k, f of m comma n plus k. Here, for example, consider this image. For example, this is 3 by 3 image. So in this, here it is 20, 30, 10. Here it is 10, 50. Here it is also 50. Here 40. Here also 40. 40, 30. Here it is 10. Here it is also 10. These are the pixel value. This image we are representing with f of m comma n. F of m comma n. So how we can increase the brightness? Here what is the formula? This is g of m comma n. Here g of m comma n equals to f of m comma n plus k. Here small f of m comma n plus k. Here the k value, for example 10. So whatever this resultant, whatever here 50 is increased, add with some value, constant value 10. Here it is 60, 50, 20, 20, 40, 20, 50, 50. So like that we can increase the brightness of the image. Here it is enhanced image. So this is original image. So this is brightness or enhanced image. So in this case, the original image is f of m comma n shown in figure. The enhanced image is g of m comma n. Here the value of k is chosen by 50. Here each and every pixel in f of m comma n is increased by factor of 50. Here AB. So here the image, it is I1. So in JPEG format, here A, the image, here it is, we are representing the image is A. Add with 50. The constant value is 50. Here the image shown, the title it is here original image. We are representing with title is original image, and the resultant image, each and every pixel add with some value 50. Then here the resultant image, the title here we representing with enhanced image. So this is the MATLAB code for increase the brightness of the image. Here, how we can decrease the brightness of the image? Here, g of f of m comma n, it is the input image. Then g of m comma n equals to f of m comma n minus k. So here, each and every pixel of our input image subtract with the k value, then we can decrease the brightness of the image. So observe here, this is original image, and here we are subtracting the each and every pixel. Subtract the each and every pixel with some constant value. Then this is our suppressed image. So here the brightness is suppressed by subtracting a value of 70 from each and every pixel of the original image. So here what is the code here for this one? For this one the code is nothing but only thing is here in this code we are representing with here it is A. We are representing with A, next B. So how we can subtraction means use minus 70. Use minus 70. So that same program in this A double equals to minus 70. So subtract with minus 70. So that is for decrease the brightness of the image. And next, contrast adjustment. So in this contrast adjustment, here scaling of all the pixels of the image by a constant k. It is given by g of m comma n is nothing but here it is output. Input is f of m comma n into k. So here the changing the contrast value we can increase or decrease. So changing the contrast of an image changes the range of luminance values present in the image. So observe here, specifying the value above 1 will increase the contrast by making the brightness sample brighter and dark samples are darker, thus expanding on the range used. So here this is original image. A value below 1 will do the opposite and reduce the smaller range of values. So increase in contrast, and here decreasing contrast. So how we can adjust the contrast adjustment means based on the value, based on the gray level values, we can increase or decrease. So up to here point, what is mean by image enhancement, what is the need of image enhancement, and in this we are having in image enhancement we are having spatial domain and transform domain. In the point processing operation, we are having histogram process is main important, and brightness increases and decreases, and contrast adjustment. So today's session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.